Welcome to the third episode of the PuTTY series. In our second video, we successfully completed the entire hardware assembly and built a physically flawless beast. We precisely mounted the Ardicum sensor, the true heart of the camera, integrated the Raspberry Pi alongside the UPS power line, and finally secured the screen interface into the custom 3D printed case. Now it's time to give this powerful body its mind. In this episode, we'll examine step by step how to set up the open source app that I wrote myself for PuTTY. If you love these kinds of open source projects and want more videos like this, don't forget to subscribe to the channel. If you're ready, let's jump into the first step. We need a micro SD card, because this card will serve as PuTTY's main storage, essentially its hard drive, holding both the operating system and the custom app we wrote. For this video, I'll be using a 64GB card. We take our micro SD card, slide it into the reader, and then plug the adapter straight into the USB socket of our computer. Next step, we head over to the official Raspberry Pi website. We click on the Software tab from the top menu, and from the page that opens, we download the Raspberry Pi Imager software by choosing the appropriate option for our operating system. Since I've already installed the Imager software on my computer, I won't show that part again just to keep the video from dragging on. The installation process is pretty straightforward anyway. You can get it done in seconds by just following the standard setup steps. As a first step, we select Raspberry Pi 4 from the device list on the left. Next, under the OS tab, we click on Raspberry Pi OS, Other. From the list that opens, we find and select Raspberry Pi OS, Legacy 64-bit Lite, and click Next to move on to the SD card step. Under the SD card tab, we select our connected card and click Next. On the customization screen that appears, we define a host name for our device. Under localization, we set our region, time zone, and keyboard, then click Next. Under the User tab, we set a username. Right below, we enter our password. Make sure not to forget this password, as we will definitely need it later during the setup process. Now, we click Next and move on to the next step. Since I've already entered my Wi-Fi password before, I don't need to do this step now, but make sure you enter your own network name and password here. Make sure your SSH settings look exactly like this, as we will definitely need SSH later for remote access. After clicking Next, we hit Right on the summary screen to proceed. Once we accept this option, warning us that all data on the card will be erased, the Imager tool starts writing the OS to our SD card. This part takes a little bit of time depending on your card speed. Your SD card will be fully ready in about 5 minutes. Once the process is complete, we click Finish to wrap it up. I speeded up this part so the video wouldn't drag on too long. Now that our card is ready, let's move on to the next step. We remove the micro SD card from the computer, insert it into the Raspberry Pi's SD card slot, and then power up our Raspberry Pi. As you can see in the video right now, I've powered up the Raspberry Pi and it's booting. After the logs scroll by, an IP address will appear on the screen. We are doing this step solely to find out its IP address, as we will definitely need it in the next step to connect from our computer. Make sure to note down this IP address, as we will need it to connect from our computer. Now, for the next step, we go to the official FileZilla website and click on the Download FileZilla Client button. On the following page, we click the Download button again to get the software onto our computer. To keep the video from dragging on, I won't show the installation steps. I already have it installed, and the setup is pretty straightforward. After opening FileZilla, we access this screen by clicking on the Site Manager button in the top left corner. We click on the New Site button on the left to create a new connection. Then, under the Protocol section on the right, we must select SFTP, SSH File Transfer Protocol. Right below that, in the host field, we type in the IP address we noted down earlier from the Raspberry Pi screen. After entering the IP address in the host field, we set the logon type to normal. In the user and password fields right below, we enter the username and password we created earlier in the Raspberry Pi Imager tool. Finally, we click the Connect button at the bottom to connect to our Raspberry Pi. Once the connection is successfully established, we right-click on the empty space on the right side and select Create Directory. In the window that pops up, we name our new folder Camera_App and click the OK button. After the folder is created, we select all of our project files ready on our computer, drag them into this folder, and start the upload process. While the upload continues, I'm speeding things up a bit here so the video doesn't drag on. With this step, we have completed all the preparations and file transfers on the computer side for our project. Now, without wasting any time, we are moving straight to the most exciting part of our project, the next step, where we will run these files via the terminal and bring our system to life. If you don't have PuTTY installed on your computer, quickly download it from the internet and open it up. In the hostname field on the screen, type in your Raspberry Pi's IP address and click the Open button at the bottom. On the black terminal screen that appears, enter the username and password we created earlier to log into the system. Then, we execute the following commands in order. First, type cd camera_app to enter the folder where we uploaded our project files. Run the source camera_venv/bin/activate command to activate our virtual environment. Finally, enter sudo bash setup.sh to start our project's installation script. Everything is that straightforward. This installation process takes about 5 minutes on average, depending on your internet speed and card performance. As you can see in the video, once the processes on PuTTY are successfully completed, the rest of the installation automatically reflects onto the camera screen, and the setup continues running smoothly right there. The installation will continue until the progress bar on the screen reaches 100%, and once complete, the camera will reboot on its own. From then on, every time you power up the camera, the PuTTY application will launch automatically without requiring you to enter any commands, leaving you completely ready to take videos and photos right away. And the moment has finally arrived. The installation process is completely finished, the progress bar has reached 100%, and our system is perfectly set up. Now, we are fully ready to see our project working live, watch the screen transitions, and experience those wonderful results with our own eyes. Our camera application is finally open. As you can see, our interface runs incredibly smoothly, and all the menus respond instantly. Now let's take a look at the outdoor shots I took to test the system. Let's watch those wonderful videos and photos from my Cappadocia trip together. To make sure you don't miss out on more new and exciting DIY projects like this, don't forget to follow us, leave a like, and subscribe to the channel. See you in the next video with brand new ideas. Take care of yourselves, and goodbye.